Hi, my name is Matt Maxwell, and I'm the product manager for Tektronix Real-Time Signal Analyzers. In this short video, we will take a little deeper look at some of the unique advantages of Tektronix Real-Time Signal Analyzers that are not available from any other manufacturer. Real-time signal analysis is becoming increasingly important in the world of RF design. As there are more challenging wireless devices to develop, new tools in spectrum and signal analysis are needed to fully understand and characterize the wireless data being transmitted as it changes over time, including discovering transient signals, glitches, data bursts, and other potentially unintended but important signal behavior. With our competitors now offering real-time spectrum analysis capabilities, the point is underscored that this capability is becoming a vital tool to complete designs, manage the use of spectrum, and troubleshoot some of the most difficult issues that arise from today's modern devices. We believe most, if not all, of the features that we will talk about today are unique to Tektronix real-time signal analyzers and not available from any other manufacturer. The first key point to show is how Tektronix has established the most advanced real-time signal analyzer. In this example, we see the DPX display, which in this case means digital phosphor spectrum. Here, the RSA displays nearly 300,000 FFTs a second. The RBW, or resolution bandwidth, is quite flexible here, and I can control this like a traditional spectrum analyzers. Here we are looking at the instrument's entire 110 MHz real-time bandwidth. Additionally, I can increase the instrument span to wider than the real-time span to show how SWEP DPX can capture wider bandwidth signals. Tektronix real-time signal analyzers are the only instrument to have this capability. For a wideband pulse, such as shown in this example of many overlapping pulses, this feature could be useful to show transmitter signals under the pulse signals of interest. Low-level signals underneath the pulse signals coming from a radar transmitter could potentially interfere with a receiver's function in an actual radar system. Now we see DPX with an antenna attached to the RSA's input. We can see the signals being used for 3G and 4G cellular wireless base stations and the unlicensed ISM band around 2.4 GHz, as well as some other signals. Another example of how SWEP DPX could be useful for spectrum managers is to see a wide range of signals looking for signals of interest. Additionally, we can increase the dwell time per step to see longer in each step. This might be useful, for example, to watch the entire rotation time from a radar as an airport's antenna sweeps around. None of Tektronix's competitors offer the SWEP DPX capability, which can be important both in spectrum management applications as well as research and development applications when larger than real-time bandwidths are necessary. One of the other key features for any real-time spectrum analyzer is to have frequency selective triggers. Here, Tektronix leads the way with an easy-to-use DPX density trigger, as well as having frequency mask trigger, frequency edge trigger, and applying time qualification to any of the instrument's triggers. For this demonstration, the DPX density trigger, also called trigger on this in the user interface, lets you trigger on any signal that you can see on the DPX screen within the RSA's 110 MHz bandwidth. We have a demonstration board here that mainly generates a continuous wave signal, but becomes unstable about once every 1¼ seconds. We are watching the spectrum and DPX displays here side by side. We can see on the max hold trace that sometimes on the spectrum display the transient signal event is captured. However, with the DPX spectrum display, this transient is much more evident. In either research and development or in operational spectrum management, it can be important to trigger on the signals of interest and to do something about them, whether that is to investigate an infrequently occurring signal coming from an RF transmitter or some unexpected signal in the licensed spectrum band. Here we use the RSA's DPX density trigger turned on using simple mouse clicks. Note that this automatically sets up the instrument to trigger on the transient signal. When I did the right click to activate this trigger, several things happened automatically. First, the box was activated with a predetermined size and the signal density over time was measured. Now, this signal density is different from that measured in other spectrum analyzers because it's measured over a period of time. Next, the trigger threshold is set to a level just below the measured signal density over time. Last but not least, the instrument's trigger was turned on to start the triggering. This DPX density box is adjustable by the user. This trigger lets you trigger on any of the signal that you can see on the DPX spectrum screen by positioning the box and adjusting its size. This is easy to do with the mouse graphical user interface in the RSA. Now, with some adjustments, we can show the complete transient. We are looking at the DPX spectrum display that is still running, but upon each DPX density trigger, the instrument is capturing and analyzing 1 millisecond of signal data. The other displays shown are the frequency versus time display, which has the frequency relative to the instrument's center frequency on the vertical axis versus the capture time shown on the horizontal axis. The spectrum and spectrogram displays are also shown. One of the important aspects of Tektronix real-time signal analyzer is that most all of the capabilities are integrated into the instrument software. Furthermore, if we put on markers to measure the transient that we have captured, we can perform a direct measurement on either or both the frequency versus time measurement or the spectrogram. The spectrogram shows the signal history over time, with the most recent signals appearing at the bottom and the oldest signals at the top. Last, the spectrum displays orange trace corresponds to a time slice of the spectrogram. This means that you can walk through the entire signal transient by simply adjusting the timing offset of the marker within the spectrogram. This is important because none of our competitors offers integrated displays and correlated markers. When troubleshooting real-world problems, getting to the root cause of a problem can be a very difficult and time-consuming prospect. This issue is not just to see the glitch or transient, but pinpoint it in time and investigate this in different domains to best understand why a particular signal anomaly is occurring. With the RSA's integrated displays and markers, this can be made as easy as possible. To summarize, in these short demonstrations, we have highlighted several unique differentiators that our competitors lack. Tektronix RSA has swept DPX, which allows for signal discovery outside the instrument's real-time bandwidth. With the industry's most advanced frequency domain triggering, the RSA has DPX density trigger that allows you to trigger on any signal that you see on the DPX display, including signals under signals. With the integrated user interface and correlated markers, we show how the RSA can help troubleshoot difficult signal problems in research and development, or to be useful to fully characterize signals of interest in a spectrum management operational application. The Tektronix Real-Time Signal Analyzer is the industry's most integrated and capable real-time signal analyzer. I thank you for watching.